down here, and it's what kinetic energy is up here. So, all right. Let's see, we started this one on Friday. Can I peek again? How far did we get? Okay, not very far. We did total energy, and that's about it. Okay. On the second example, after this one you'll be able to do your assignment. So please, this is the longer of the two, so give me your brain for about 5 minutes so we can see how these work. On this scenario, when you pull it down from equilibrium, we went down 12.3 centimeters. That's where we're going to hold it and release. And it's going to come up, and we want to know the speed when it's up only 8 meters from the equilibrium. This time, we will have to go the path that we started over here. There's no real shortcut. So the first step on these kind is to find the total energy. So, MK, tell me again, where do I go to find total energy?
You go down to the amplitude.
Amplitude, right. All right, so we're going to go down to amplitude where all the energy is potential. So we're going to use potential energy formula. So I'm saying PE is TE, and look, I put a little subscript there so you know I'm looking at the potential energy at amplitude where I pulled it down all the way. All right, total energy, there's no KE there, so all of the energy is potential, so I can go there and find total energy. So it's going to be 1/2 K X. What's X at amplitude in this one? 0.123. Because we're using meters, and that's squared. K, did I give you K?
Yeah, it's 46.
I did? Okay, so I failed to put that up here. 46? Okay, that's helpful. So we have 46, so this is the 1/2, this is the K, and this is the X squared. All right, calculate that, or did we already? What was it?
0.35.
0.35 joules was our total energy. All right. If you remember when we studied the roller coasters on the hills, we did this exact kind of thinking. Now, we're going to take the fact that total energy equals the sum of potential and kinetic and find what we need. And the question is speed, so we're looking for this right here. So putting in what we know already, we know total energy is 0.35 joules. 0.35 joules. Total energy is 0.35. Potential energy, we're looking now at 8 centimeters from equilibrium. So this thing is going to go up to here. And that's where we want to find potential energy. So, Emily Martin at PE, at PE at 8. Could you give me the correct numbers for potential energy at 8? So this is a 1/2 kx squared here.
K, is K still 46?
Yep.
Okay.
And what's x at this point in our problem?
8.
Right.
Okay.
So we're going to switch it though to, would you switch it now to meters?
So 0.08.
Right, and that's squared. So that's our potential energy, plus our kinetic. So Brandon, you grab the kinetic energy and just give me the numbers at this position here. So we just want numbers for this, this, and this. Obviously that's 1/2. And then what's the mass? Did I give the mass?
Yeah, you did.
I didn't give much, did I?
0.023.
All right, on Friday I gave the mass, but I didn't re-give the mass. So,
and then
and so what is it in kilograms? How many times do I move that decimal from 23 to get kilograms?
so with
Right.
0.02.
Yeah, 0. I dropped that first 0. You love that first 0. Go for it. All right, and then, so you have given me this, and v squared is what we're looking for. All right, solve that. Anyone got it? I'll peek at it. Yeah, let me
I see. Got it.
Called it, yes.
And just put in a unit. Did you get ahead? I'm
No.
gonna tap it out. Oh, you can use my calculator. You're still better.
Yeah,
Here's
I
my
forgot to
wallet.
put
Did
it.
you get 4.2?
And I told myself to.
I keep
and
meaning to
couldn't
bring
get
them,
it.
so I'm doing just as bad.
Oh my, one.
Oh crap. No. Man.
What you got?
Base. Yeah, base. See what that gets.
The first part. All right. Alex, mathematically, peeking at your calculator, are you taking this number, subtracting this number,
Yeah.
and dividing by this number?
Yeah.
Okay, just making sure, I couldn't tell. All right, did you get something?
It's 4.2.
Sure. Yep. Add 2
You get one?
I got 1.1.
Yep. All right, and that's a velocity, so meters per second. Yeah. All right, I'll look and see.
That has been the funniest part.
Is that say 35? I think it's
Yes,
.35.
yes.
Okay, all right. Looked like you had the right order, but just the wrong
Yep.
decimal there. All right. All right, for those who didn't get it, I'll come by and see why. Everyone else, we're gonna do 6 of these kind. I'll leave those up so you can see the procedure. And they are on your own, 6, 7, and 8. There's some books up here. You didn't bring yours, that's fine. And practice problem 6, 7, and 8.
Yes.
So video land, we're gonna sign off for a little bit. We should show them the work. Can you get your book open? And just in case they don't have your book.
Yeah, that's what I got.
All right.
Oh, thanks.
You can probably use Brian's and here's the GSW. There's also this one.
I can get, there's one up in my room, or whatever you call that, Miss Sean's room. So I gotta get another one. Who else needs one?
I don't think anyone.
Okay, we're okay. All right, thank you. All right, I need to show the work in probably gone over 15 minutes, but I can split it up.
Yeah, sure. Yo, you got what? 4.5?
I got
6.
Yeah, 4.5 so was mine.
Yeah, then that'll be it. There it is. Show
Only the first
those.
digit right were kind of good, so.
What?
And then the practice problems are right after that.
What'd you get, dude? Well, I don't know.
Is that good?
I didn't get that.
All right, they can freeze the frame, pause it. Yeah, keep going. It's at the end of all that. Hey, all right, and 6, 7, 8,
Only 4, yeah.
and then just tell them goodbye.
Alright.
Alright, wait.
See what's in the video.
Oh, wait, do all that? Oh.
6 problems.
6 problems.
6 whole problems.
6 whole problems. You death of me.
All right, in about 15 minutes, if not sooner, I will end this, and you can finish for homework.
Alrighty.
I am going to
Signing out.
discuss something else.
Bye, I'm Keen.
March Madness
All
opening
right.
day.